Write these two inequalities down. 3x minus 10 is greater than 8, and then minus 3x minus 10 is greater than 8. First of all, what do you notice is the difference between the two equations? Anybody? It's small, yet significant difference there. Morgan?
The 3x is negative.
Okay, this 3x is negative. When you see the letter, the term that has the letter in it being negative or subtracting or whatever you want to call it, in your mind you should think, oh, something's going to be different here. Think that, okay? Let's look at the one where it's not different. How do I figure out what my inequality is, or how do I solve this? Just like an equation, the first thing I'm going to do on a career check is I want to get the x by itself, so I have to get rid of this, I have to get rid of that. What do I have to do first? Right, you always get rid of the plus and minus stuff that's away from the letter first. So I add 10 to both sides, I add 10 to both sides. I'm going to get 3x is greater than 8. Same thing is going to be true over here. I'm going to add 10 to both sides, add 10 to both sides. That should be 18. I get negative 3x is greater than 18. So far they're very similar, the same. How do I solve this one here then? Nate, just
divide 3 by 3 and then 3 by 18.
divide by 3, divide by 3. So x is greater than, well, 6, right? X is greater than 6. And if you were asked to graph it, just means you would do what? Put an open circle at 6 on the number line. It's all the numbers that are greater than 6. That's where things kind of go different on this one here. Okay? You are never ever allowed to have the x term be negative. Okay? So I need to make that positive. Which means simply, there's a couple different ways you can think about it. Let's just think about this. If I divide by 3, and I divide by 3, I end up with my negative x being greater than 6, right? Since I'm not allowed to have that x be negative, I can change it to a positive under the condition that I change everything else to its opposite, including the inequality sign. In other words, I can make this positive, and I can make this negative 6, but I have to change the sign to its opposite. Okay, and that's kind of the fundamental thing. If by multiplication or division you change the sign of the variable, you have to change the inequality sign too to its opposite. You change variable, I can change inequality. How's that? Two. And I'll show you a couple more examples of that.
Mr. Hahn, do you have room?
I don't, thank you very much. There might be one in my office though, I don't know. What happened, accident, problem?
Someone spilled nerds on the floor.
Still who?
Nerds.
Are you having a party?
No.
Wait, what is the sign of
If
valuable?
by multiplication or division you change the sign of the variable, you change the inequality too. Again, this is best shown not so much by words, but by actually doing the problem. Let me just do a couple of them here. If you have negative 6x is less than 12, or if I have 6x is less than 12. Okay? Rather than dividing by 6 and then changing the signs, you can do it all at one time. In other words, you can divide by a negative 6 and divide by a negative 6, because that'll make this positive. Negative 6 divided by negative 6 is a positive. So I end up with a positive x there. But since by multiplication or division I changed the sign, I must change that to its opposite. And 12 divided by negative 6 is a negative 2. Whereas in this case here, I still divide by 6, divide by 6. If it wasn't negative, I didn't change the sign, the inequality stays the same. At any time you change that term by multiplication or division to its opposite, the inequality changes to its opposite too. Morgan?
It's still negative though.
What's still negative? My x isn't. I only care about the x being negative. My number over here can be negative. Okay? This number is fine to be negative, it's the variable that can't be negative. Ken?
I have 2 questions. When you change, like, if it's a negative on that, you always have to change it.
If you change the sign of the term that has the letter in it, that sign is going to change too.
And
Not just any old numbers, it's just when it's that, then you just change. And do I have to what?
graph it like the line.
If it tells you to graph it, then yes, which would simply be this, at negative 2, open circle going this way. This one, positive 2, open circle going this way. If it tells you to graph it, you have to graph it. Let me give you a couple, straight out of the book. And I'll have you do these here. Minus 5x minus 6 less than negative 1. And then how about this one? Oh, wow. We get a little crazy on this now. We have to do a hard one here. Actually, do this one first, and then I'm going to do the really hard one for you. See what you get when you solve this. Solve and graph. Solve this and graph. And again, it's only when you change this that that sign changes, not when you change that. Only the x1. Only the x factor.
And graph it.
And graph. Why not? There should be plenty of time. Okay. Can I get rid of this first? I add 6. I add 6. I add 6. Okay. I end up with a minus 5x less than positive 5. Don't change the sign, because I didn't change the sign of the variable term. I can do whatever I want by adding and subtracting. It's not going to change the sign. Okay? It's only when you multiply or divide. Now to solve this, if I want to get x by itself, I divide by a negative 5, which is going to change this sign to a positive. That's going to change that. Divide this by a negative 5, I get negative 1. And the graphing of that at negative 1 is an open circle going this way. Closed circle would be if there was an equal sign on the bottom. Then this would be equal. Kendall,
When you added 6 onto the, oh wait, no, that's negative. I was wondering why it wasn't.
now comes the difficult one. Write down this one, ladies and gents. We haven't done anything quite like this. Negative 2x plus 3 is greater than or equal to a negative parenthesis x minus 7.
Does this be distributed properly?
Well, I'm gonna do it for you, so don't, I'm not asking you to do this. Listen carefully. Your first thing, before you worry about anything, is you want to simplify both sides or see if you can change them to make them easier. This one, there's nothing you can do it for right now, so we'll rewrite it, negative 2x plus 3. This one over here, somebody said it. I've got this parenthesis, so I'm going to distribute out that minus sign. So a minus times an x is a minus x. And I'm not changing signs, by the way. And a minus times a 7 is a plus 7. I wish we'd stay there. Now, my next step is to get all of my x's and all my numbers on one side. Okay, now here's what I talked about. I can move this x over here by doing the opposite to it. What's the opposite? Adding x. A negative x plus an x gives you no x's over there, but changes this to a minus x on this side. Now, I didn't change the sign there because, remember back before I said, if you change it by multiplying or dividing, I didn't multiply or divide this, I added it over there. It's only when you multiply or divide by a negative that you change that sign. You can add and subtract stuff all you want, it's not going to change the sign. It's only when you multiply or divide. Okay, now I have plus 3. How do I get the x by itself now? I subtract 3. So a negative x is greater than or equal to 4. And it's at this point here, at the very end, when you get it down to the x term and that number over there, if I have to change the sign of this, I have to change the sign of everything. So it ends up being a positive x is less than or equal to a negative 4. Change it to its opposite, opposite, opposite. And if you were graphing it, it would be at negative 4. This. Fortunately, we'll get lots of time to work on those. Guaranteed by the time you're in 8th grade, it'll be just like
No.
which part where? Somebody throw me what they didn't understand why, what happened. Caroline!
On the last example, that made it so that the circle was part of the line.
Because the line under the equal sign. The line under
On the
the.
last.
Oh, I made it because somebody asked me and I just said, well, if this is what it is, then I change. I colored it in because somebody asked me about it. It shouldn't have been originally, no. Again, question, somebody don't understand, you're so confused about what part. No, you can't do that. Taylor? Why, what happened? At what stage?
After you wrote down the problem, you kind of lost me after that.
You don't understand the distributive properties.
Well, I don't understand what the whole minus sign was right there, like.
This one?
No,
This
no, yeah.
It's a minus or a negative 1. Either one. It doesn't matter what you call it, but you gotta get rid of it by multiplying it by both things inside the parentheses.
So
A
then why
negative
did
times
you?
that is a negative x, a negative times a negative is a positive. One negative makes a negative, 2 negatives makes this positive. I can tell you we've done that before. Many times. That's where this came from. And then even before we've done this before, anytime you have an equation, inequality, they're all the same. You get your numbers on one side and your letters on the other. So you do the opposite. add x, subtract 3, subtract 3. And then it's just a matter of that last thing there. Don't worry, we'll get to more of those.
Very